Again, and today we're going to be looking at the January CSEC paper for 2019. All right, so the January paper for CSEC mathematics. All right, again, we have 2 hours and 40 minutes, and you fill out these pages and you do your thing. 2 hours and 40 minutes is on the clock, and 7 questions is from section 1, three questions is from section 2, and you do everything. All right, so the formula sheet here again. Anytime you cannot remember a formula, come back to here. Volume of cylinder, volume of prism. Anything you can't remember, just come back to here. Volume of right pyramid. Always come back to here if you can't remember a formula. All right. So let's begin. And of course, we start with question 1. It says evaluate 3.8 times 10 squared plus 1.7 times 10 to the third. Now, how I want you to look at this is always know that you work out the multiplication part first, BODMAS. You're going to use BODMAS. So you work out this first, 3.8 times 10 squared. 3.8 times 10 squared is 380. Plus, then you work out this next. You work out 1.7 times 10 to the third power. 1.7 times 10 to the third power, that is 10 to the third power is 1,000. 1,000 times that is 1,700. So this is what we have. And so this works out to be 380 plus 1,700. And I think this is going to give us 2,080. But then the question says, given your answer in standard form, put your answer in standard form. So the answer is going to be 2.08 times 2.08. And if you want to just be specific, 2.080 times 10 to the third power. Why to the third power? 1, 2, 3. 3 units are going across by 3 to the right will give us back 2,080. And that's how you do this question. So that's the answer, easy. Some persons, if you want, would just put it straight away in your calculator. Put it straight away in your calculator. And when you put it straight away in your calculator, that will give you the correct result. All right, and that takes care of part I. Luckily for us, part 2 is fractions. It couldn't get any nicer. We have a fraction. So part 2 give you a piece of fraction, and it says, given your answer as a fraction in its lowest term, work out this. So first thing, always work out what's in the numerator first. So 1 times 3 is 3 over 2 times 5 is 10. And that is, of course, being divided by what's in the denominator. Now, the denominator is 3.5. And 3.5 as a mixed number is 7 over 2. And so, what we have is 3 over 10. And 3 over 10 is being multiplied by, when you're dividing, you flip it and change the sign to multiplication. So it's being multiplied by 2 over 7. And that's it. 2 can go into itself 1 time, and 2 can go into 10 5 times. And so the result that we are obtaining clearly is 3 times 1, which is 3, over 5 times 7, which is 35. So that is your answer, 3 over 35. Now, of course, You could have just done it with your calculator. Don't be afraid to use your calculator. Just use your calculator and it's going to give you the correct answer in the lowest term. So just plug all of this in your calculator and write down 3/35. All right? Nice. Now it says express 6 as a binary number. Now what is a binary number? A binary number is a number that involves only zeros and ones. Nice. So look at this now. So what we're going to do is I'm going to draw a table. All right. This is just the way I've been taught to do it many years ago. And I think it's a simple approach. All right. The binary are numbers that are used for zeros and ones, and binary mean 2. We use the base 10 system. All right, where we use 10 to the 0, 10 to the 1, 10 square and stuff like that. 10 to the 0 represent ones, 10 to the 1 represent tens, 10 square represent hundreds and so forth. But in binary, you're going to use 2 to the 0, 2 to the 1, 2 square, 2 cube, and 2 to the 4, and so on. All right. Now, where would 6 fall? What will 6 be comprised of? Well, 6 will be comprised of, first and foremost, it is 2 cubed is 8. So no, this is not going to work out. But we know that 6 is going to comprise of 2 to the 1 and 2 to the 0. Now when you add these, oh, I left off 2 square, my apologies. 2 square is left off. 2 square is 4. So it's going to have a 4 in there. 2 to the 1 is 2. And I put a 0 here. So this is 6. So the number 6 in base 10, remember 6 is always in base 10, it's actually equal to 110. This is it as a binary number, 110. All right, why is that so? Because look in the table, 2 square means 4, 2 square means 4, plus 2 to the 1 is 2, plus 2 to the 0 is 0. All right, and so this gives us the number 6. All right, so as a binary number, it is 110 to base 2. That's binary. All right, nice and easy. Now let's go to the next part now. The next part is consumer arithmetic. This consumer arithmetic says John bought a car for $65,000. So John buys a car for $65,000. If the value of the car depreciates 8% each year, how much will the car be worth at the end of 2 years? So it's going to depreciate for 2 years. So it depreciates by 8%. So if it depreciates by 8%, it's worth 92% of this amount at the end of the first year. So at the end of the first year, this is what I want you to do. All right, at the end of the first year, this is how much the car is going to worth. At the end of the first year, the car is going to be worth 92% of 65,000 because it depreciates by 8%. So it's worth 92% of 65,000. So what is 92% of 65,000? You work that out. That is going to give me, you just put in your calculator 0.92 times 65,000. That's going to give you 59,800. That's how much it's going to work at the end of the first year. Now we need to find how much it's going to work at the end of the second year. Now this is what the car worth now at the end of the first year. So at the end of the second year, how much the car actually worth is going to be 92% of that 59,800. So it's 92% of 59,800, right? So his car is depreciating a lot of money. So at the end of the second year, how much it works is you put in your calculator 0.92 and you multiply that by 59,800. And that gives you $55,016. So that's how much his car worth now, $55,016, which is not bad. It lost just about $10,000 off its price in 2 years. Depending on the currency, if it's USD, that's a lot of money, but otherwise it's pretty fine. All right, and so that takes care of that. Now, this question says, the table below shows the results obtained by a student in her CSEC mathematics examination. The maximum mark for each paper is given in the third of the column. All right, so for her paper one is the MCQ. She obtained 55% out of the 30. Paper 2, she obtained 60% out of the 50. Paper 3, which is her SBA, she obtained 80% out of 20. It says, determine as a percentage the student's final mark for the exam. So determine the student's final mark for her exam. All right. Now, there are many ways we can do this question. There's what is known as the weighted mean, and don't want to use weighted mean, but if she obtained 55% of 30, that means her actual marks, I'm going to put a new column right here called actual marks. All right. There's a new column called actual, AM stand for actual marks. You should get 55% of 30. You multiply 0.55 times 30. You multiply 0.55 times 30. So that means she got 16.5 out of 30. If she got 55%, she got 60.5 out of the 30. All right. Now for her paper 2, she obtained 60% of 50. To get 60% of 50, that's 0.6 times 50. And so she obtained 30 marks out of 50. And for her SBA, she get 80% of 20. And so she got 16 out of 20 for her SBA. So you're gonna add these up now, and the total is how much marks she get out of 100. So she gets 16.5 plus 30 plus 16. That's 62.5. So she barely passing. Thank God for her IA, right? Or SBA or her IA. Her internal assessment was pretty good. The school-based assessment. So paper 3 saved her. So she barely over that. So determine as a percentage the student's final mark. So this is the weighted mean method. So the weighted mean is going to be equal to, how the weighted mean works, it's 0.55 times 30 plus 60 times this plus this times this. So her weighted mean is 0.55 times 30 plus 60, well, not 60, it's 0.6 times 50 plus 0.8 times 20. And that will give you her percentage, the weighted mean. That's what they call it, weighted mean. And you work out her weighted mean, 0.55 times 30 plus 0.6 times 50 plus 0.8 times 20. And so see it there, she gets 62.5%. All right, so she's not doing too badly, but that's what she gets, 62.5%. Some persons might want to round it off to 63%, but I'm not sure if CSEC round off as yet. Do they round off? I'd leave it at this, 62.5%. So let us argue, let's make a debate. Do you think this girl got a 1? I highly doubt it. A 2? I highly doubt it. I think she gets a 3 in mathematics based on her grade. Just being realistic.